Welcome to a quick little discussion of domain and range. This is Miss Ozanich, and this is an Algebra One video. And I hope you guys are doing good this week and able to make it through all these new ideas that we're playing with. So let's go ahead and get started. And I have 3 videos for you this week. We'll start with page 4 in your workbook. I believe this is page 4. We're still trying to get page numbers kind of fixed up. So if I make an error with page numbers, just give me some grace and we'll kind of get it ironed out as we go through the week. But I believe this is page 4 from your workbook. So we're going to talk specifically today about domain and range and this idea of some key features. All right, so this is a graph, a picture of a toy rocket after it has been launched. So you can see that there is information on your graph about the time in seconds on the x-axis and the height in meters along your y-axis. So we can see that at time 1 second, that, for example, our height in meters of our toy rocket is 40 meters. So that might be a key point for us to understand that if we plot any point along this graph, that is going to be at what time the rocket is a specific height. Okay, so let's go through and we're just going to answer some of these questions together to give you guys an idea of what to look for in terms of key features of your graph. Okay, here we go. What do the numbers on the x-axis represent? Well, we've talked about that. We looked at our x-axis and the numbers represent time in seconds. Okay, always super important to remember what labels we have and what our numbers are actually representing and what they're actually meaning. The numbers on the y-axis represent height in meters. Oops, pen. So just write that in here. You can write that along with me if you'd like on your own workbook. What does the point 140 represent on the graph? Well, we talked about that point, that at 1 second, we're plotting that point 140. So it must mean that at 1 second, the rocket is 40 meters high. Okay, just kind of getting that written in there. What is the relationship between the x-axis and the y-axis? Okay, well, the x-axis is giving us time. The y-axis is giving us meters. They're not, the numbers aren't exactly written out the same, and that's okay, because we need to express much more height here. Okay. The x-axis and the y-axis are often also called the independent and dependent axis. So if you're trying to figure out which is which, the height is dependent on the time. So our height, let's see if I can write this in here, is our dependent variable, and our time is our independent variable. Okay, so that's going to be a relationship between the x-axis and the y-axis. Okay, key features. Let's talk about key features that are unique to this graph. Well, this graph, because it's U-shaped, it could be upside down U, it could be a right side up U. We know that it is going to be a quadratic. And because it is a quadratic, it's also going to have a maximum or a minimum. Which one do you think this one has? Do you think this one has a maximum or a minimum? So a maximum is going to be the point at the top of the mountain, right? And a minimum would be a point that's at the bottom of the valley. be the minimum. So because this graph is shaped like an upside down U, it has the top of the mountain, it has a maximum. And we can actually talk about that key feature of a maximum in terms of its actual point. So let's see where that happens. At 5 seconds, it looks like the rocket, not quite 120 meters, maybe 118 meters. So that maximum is happening at a point, and that point is the point 5, 118 meters. Okay. Other key features might include x-intercepts. So we have an x-intercept here and here. Those x-intercepts are important because in this model, the x-intercepts represent the ground, right? For our toy rocket, the x-intercepts represent the ground. And then over here, the y-intercept is also at 0, which represents the rocket taking off, not already up in the air somewhere, like off a platform or off a building, but the rocket's actually being launched from the ground. So your y-intercept becomes important as well when we think about key features. Okay, so x-intercepts and y-intercepts, maximums and minimums. Let's go on to the next question here. Does it make sense for the x-axis to be continued to the right indefinitely? Or what about the left? So this is kind of a question that is wondering, what should our domain actually be? Does our number of seconds need to go past 10, for example? In this example, I don't think it does, because the rocket is launched, the rocket lands, and then you're kind of done with your experiment. So because our x-axis is related to our domain, we're going to state our domain for this function as going from x values that are greater than 0 and less than or equal to 10. Okay, that's going to be our domain. The range, okay, because I did want to get to this idea of domain and range with you in this example. The range for this problem is going to be as low as the y values go and as high as the y values go. Okay, so the y values are going to be denoting your range. So it looks like the range is anywhere from 0 in this case to 118 meters, right? So remember that your domain is going to be along your x-axis, your values from left to right, and your range is going to be along your y-axis, your values up and down. We'll talk a lot more about domain and range, but that's a way to kind of get you started thinking about domain and range. And I think these are good intervals for the creator of this graph. I think the x-axis in terms of seconds is pretty straightforward. We may have labeled the y-axis a little bit differently just so we could tell exactly what that maximum point is right here. But it's a pretty good label, and it's a pretty nice graph. So I think these are pretty good intervals. I think they did a good job. All right, guys, that's it for this example. We will continue to do a little bit more work with domain and range, but hopefully that gets you off to a good start.